In today's educative video, I want to show you another way of solving quadratic equations that are in standard form. So if you recall, standard form looks like this: ax squared plus bx plus c is equal to 0. So any standard or any quadratic equation that has this general form we say is in standard form. So up to this point, we have solved quadratic equations by factoring. We've solved quadratic equations by completing the square, and now I want to show you probably the easiest way of solving quadratic equations, that is solving for x. And really, honestly, in the real world, most people use this method because you can solve any quadratic equation using this nice formula. Now, what I'm going to do is I'm going to derive what we call the quadratic formula. Some people call it the quadratic equation. Whichever one you prefer is fine. And I'll go ahead and give you a heads up. We are going to derive the quadratic formula. I haven't shown it to you yet. You don't know what this looks like. But now this proof, or this derivation, can be somewhat confusing because we're going to do the entire operation. We're going to hit this entire thing with a math stick, but we're not going to plug in any numbers. So you're going to start seeing these variables sort of piling on top of each other, and it can be very confusing, and I completely understand. But if you get to a step to where you don't fully understand what is happening, rewind the video and watch it again and make sure that you understand every single step that I'm making. Now, here's a heads up. On your next test, I will ask you to derive the quadratic formula from the general expression or the general quadratic in standard form. So this is going to be an answer that you'll need to know on your next test. And I'll leave that Educator video up, and you guys can go back to it at any time and review it. And the good thing is that after you watch the video one time, you can fast forward through the video to the steps that you really need to review. So let's go ahead and start working with this. So I'm going to use completing the square on this quadratic equation, this general quadratic equation, to see if I can find a formula where I can just plug in values for a, b, and c and solve for x. Okay, so if I want to complete the square, the first thing that I need to do is get all of my constant terms on one side and all of my variable terms on the other side. So the way that I do that is by subtracting c from both sides, and I get a x squared plus bx is equal to negative c. Now you tell me, with the expression written the way that it is here, is it ready for me to complete the square? Hopefully at this point you are able to say, no, it is not ready for us to complete the square because we need to have a 1 in front of our x squared term. And right now we have a number a. And this number, this a, we don't know what it is. It could be 1. But just to make sure, we need to divide every single term by a to make sure that we have a 1 out here in front of our squared variable term. So the way I do that is by dividing every single term by a. And whatever you do to one side, you have to do to both sides. So when you divide this by a, you have to divide the second term by a and the third term by a. You have to divide through. Every single term needs to be divided by a. And what happens is, on the first term, my a's cancel out. And I'm left with x squared plus, okay, so we don't know what b and a are. So I have to write this in general. It's just going to be b divided by a times x. Okay, this is the same thing as that. So I have bx over a. That's the same as writing b over a times x. Exactly the same is equal to negative c over a. Okay, so now let me ask you, is this expression ready for us to complete the square? Absolutely it is. We can complete the square now using the exact same technique that we've been studying for the past week and a half. So we have x squared plus b over a times x, and I'm going to leave a gap there, is equal to negative c over a. So now this is just like those fill-in-the-blank questions that I gave you on one of our past homework assignments and on the last test. So now, you tell me, what do I need to add right here in this blank to complete the square, or to make the left-hand side of this equation a perfect square trinomial? So what do you think? What do I need to add right here to complete the square? Yeah, so hopefully you were able to say that we need to add plus, so we'll add parentheses b over 2a and all of that squared. Okay, now whatever you add to one side, you have to add to the other side to keep this a balanced equation, so we get plus b over 2a squared. Now where the heck did that come from? Now remember, when we were completing the square before, we always looked at the coefficient of the x term. And in this case, the coefficient of the x term is going to be this b over a. And when we find it, we half it and then square it. So it's exactly the same thing that we've been doing for a week and a half. So I write my b over a. We half it by dividing by 2 or multiplying by 1/2, whichever way that you want to think about it, and then squaring it. So it's exactly the same. So here we're halving b over a, and then we're squaring it to find out what we need to add to the left-hand side to complete the square, or to make this a perfect square trinomial. Now, let's work with this. We've got a fraction times a fraction. All we have to do is multiply straight across the top, and we get is equal to, okay, b times 1, that's just b. Straight across the bottom, a times 2, that's going to be a2 or 2a. I prefer to write the number first, so 2a, and then all of that squared. So, since we don't know what b and a are, we cannot plug any numbers in here and solve for a specific number, so we just have to leave it in this general form, b over 2a squared. And that's why I added it here to complete the square, and then since we add it to one side of the equation, we have to add it to both sides. Now, what do you think is the next step? It's exactly the same as what we were doing before when we were completing the square, but what do you think the next step is? Yeah, so hopefully you were able to say, just like before, since we completed the square, now we need to factor the left-hand side using that nice trick that I taught you guys. So we know that as long as we're completing the square, that we're going to have this general form after we factor an expression. Okay, so this perfect square trinomial can be factored to look something like this, but we need to add something inside these parentheses. What do you think? What do we need to add right here in this blank to factor this perfect square trinomial? So it's exactly the same as what we were doing last time. We look at the coefficient of our x term, b over a, so I'll write that over here, b over a, and we just half it. We half it, and we've got two fractions, so b times 1, that's b. And we've got a times 2, that's just 2a, so all over 2a. So we need to add b over 2a inside these parentheses to factor this expression. So we get plus, I'll do this in red, plus b over 2a. Alright, so this, okay, this is equivalent to this term here, x plus b over 2a squared. Now what we have done, I just want to clarify, when you have a perfect square trinomial, when you go from this step to this step, this is factoring. Okay, we're just using a nice trick to make it a lot easier to go from this step to that step. Now look, we have our equal sign. We bring our equal sign straight down, and then we have negative c over a, and then our plus b, I'll do my parentheses, over 2a, and then all of that squared. Okay, so before we continue solving this problem, I just want to do a little bit of cosmetic work with the right-hand side of this expression, because I don't like having two terms here, and both terms being fractions. So let's just go to the next slide and see if we can clean this up to make it look a little nicer. And I've already got it written down on the next slide. So here you can see I've just rewritten the left-hand side of my expression after I factored it here. And I'm missing the square there. Let's go ahead and put that in, square. And over here is my left-hand side. So this negative ca plus b over 2a squared, that's what was on the right-hand side of my expression on the previous slide. So now let's just hit this side of the equation, what I have written here in green, with a 4th grade math stick, and see if we can combine these two terms into one, just to make it a little easier to work with. So if you recall, as long as you have one term one term in the parentheses that's being squared, you can just take that square to each individual part. And by one term, I mean there's not a plus sign here or a minus sign, and there's not a plus or minus sign here. So this isn't being added or subtracted from anything. It is one single term that is being squared. And this is the only time that you can do this. So now I can just take that 2 to each individual part of that expression. So I get negative c over a plus, okay, take my square to the b, I get b squared. Take my square to the 2, 2 squared is 4. Take my square down to the a, and I get a squared. Okay, now here we have two separate fractions. And before I add a fraction, or add two fractions together, I need to find a common denominator. So how am I going to do that? How am I going to make this, the denominator of my first term, the same as the other one? That is, what do I need to multiply the top and the bottom by to make sure that I get the same denominator that's in my second term? So hopefully you were able to say that you need to multiply, let's get green here, negative c over a. You need to multiply the top and the bottom by 4a to make sure that you have a common denominator. And then we'll leave the next one, b squared over 4a squared. So this doesn't change my expression at all because 4a over 4a, that's just 1. So that's not going to change this first term, but it is going to rewrite it in such a way that I can combine these two fractions to make both these two terms into one single term. So you know how to multiply fractions. We've got negative c times 4a across the top, and I get negative 4ac. Okay, that's the same as 4a times negative c, negative 4ac. A times 4a, that's going to give me 4a squared on the bottom plus b squared over 4a squared. Now you can see we have a common denominator, and as long as we have a common denominator, we can just add these two terms on the top. And I don't like having the negative as my first term, so I'm just going to write this one first. So b squared minus 4ac. There's nothing wrong with that. So we do b squared minus 4ac, and we know when we're combining fractions, by addition or subtraction, we don't change the denominator. This is not like multiplication or division. Here we keep the denominator the same. So all of this over 4a squared. Now what this means is that this expression at the top, this negative ca plus b over t or 2a squared, this is the same as b squared minus 4ac divided by 4a squared. So if this expression that we derived at the bottom is the same as the expression at the top, and the expression at the top is the same as this expression on the right-hand side of my equation here, then that means I can just plug this in for negative ca plus b over 2a squared, which means that this will go on the right-hand side of this equation. So it's b squared minus 4ac over 4a squared. Okay? Now before I actually solve for x, so after you solve for x, this equation in blue, we'll need to solve for x in terms of the numbers b, a, and c. You're going to have the quadratic equation, but I want you to try this on your own first. So get out a sheet of paper and see if you can solve for x on your own. And once you think you have the answer, go to the next Educated video and we'll finish solving for x, and then we have successfully derived the quadratic equation. Okay, just raise your hand if you have any questions. Thanks, guys.